All right, g'day everyone. My name's Dale Bowie, and this is Holly Wright, and we're both software engineers at IBM Security. We're based on the Gold Coast, Australia, and we work as part of the Australian Development Lab branch. So today what we're going to do is we're going to run through a bit of a user story of what we've done with OpenStack over the last couple of years, and how we took an existing on-premise product, converted it to something that was a SaaS product in the cloud, and in doing so we realized the benefits of OpenStack beyond just SaaS. So that's what we're going to talk about today.
Good, next.
So yeah, a little bit about us. As I said, we're based on the Gold Coast, Australia. Holly, she's been with us for 1 year full-time, and she did a year internship before that. And she's been working with OpenStack with me that whole time. So part of her role was to help adapt the existing security product that we're working on and put it in the cloud for a SaaS solution. And then it rolled on to creating an internal testing and development solution.
Cool, so Dale's been with IBM 4 years full-time, and before that did a 6-month internship, and the last 2.5 years of that have been using OpenStack. He's led the DevOps effort for critical cloud security components, and also drove the internal test and development architecture for many different IBM security products. So this is our home. It's awesome. We actually have views like this outside our office window, which is really, really cool. This was actually taken on a winter's day, which is like 22 degrees, which is
Celsius,
something Fahrenheit, sorry.
Comfortable.
But yeah, really beautiful. So if you guys have a spare few days while you're over here, you should definitely head up to the Gold Coast and actually make use of your towels, because I don't think you'll get a chance here, possibly.
Yep.
So cloud is huge, and it's growing. Earlier this year, it was predicted that worldwide cloud revenue was going to grow to $247 billion, which is up 18% this year alone. Almost all of the Fortune Global 50 companies have either announced cloud adoption plans or have already started implementing them. More specifically, if you've been keeping track of IBM and its transformation over the last few years, you will have seen a company-wide push towards cloud. And this has affected pretty much every IBM product in some shape or form. This transformation has been driven by the huge groundswell of customers demanding cloud-delivered capabilities. And IBM has responded with the cloud division generating $15.1 billion in the 12 months leading up to June this year. But it isn't just the customers demanding cloud adoption. The traditional on-premise solutions have grown into monoliths that are impossible for developers to maintain, and therefore for customers to use, and that ends up making support a nightmare. In many cases, employees can't wait for cloud adoption because it provides a more robust and efficient method of making their day-to-day jobs a lot easier. So a huge number of organizations are facing the same transition, as all the statistics seem to be showing. We all need to think about how we're going to SaaSify our products, and I do apologize for using the word SaaSify. I think I made it up about 2 months ago, and it's just stuck in my head. So I've included a definition for you. We need to think about how we're going to SaaSify our products and our workflows if we're actually going to keep up with the rest of the world. So our goal today is to share how we went about solving this problem in the hope that you might be able to take away a similar sort of strategy and use it to SaaSify your own products.
Right, so the mission that we got probably close to 3 years ago now was to take the existing single-tenanted security inspection appliance that would sit on a network and sniff all the packets and protect traffic through block rules and stuff like that. We were tasked to take that product and then convert it into a SaaS solution. So the 3 key requirements that we came up with to do that was we needed to be scalable, so we could easily add additional tenants when we needed to. We needed a flexible architecture so that we could add other security components when we needed them. So we didn't want to limit us just to the one product that we were trying to solve the problem for that day. And then also multi-tenancy. So in the case of network traffic, one tenant needs to have their network traffic completely isolated from another's. So we needed to guarantee that, but also provide one tenant the ability to create their own block rules and have that separate from the other tenants. So just so happened that OpenStack satisfied all these requirements. So we were able to create a set of resources using heat that encompassed various calls to Keystone, Neutron, and Nova resources. So digging into a bit more of the three requirements. So on scalability, generally a production OpenStack would look something like that. You'd have a controller node. Obviously, this doesn't include HA type environments, but controller node, you'd have, for network intensive solutions, you'd need to split off the networking into a separate Neutron node, Neutron agents over to a separate Neutron node. And then, of course, you've got N compute nodes that run the actual VMs themselves. So with this sort of architecture, we could add additional Neutron nodes, bonded NICs, to increase the bandwidth coming into the OpenStack. And we could also add additional compute nodes to support multiple tenants. So at the time that we were scaling out, the nodes that we were buying could support just 33 tenants, so we'd add more compute nodes as required. So on flexible architecture, so heat was the thing that really gave us that flexible architecture. So for those that don't know, heat is the orchestration utility within OpenStack. So it allows us to define a template that defines all the networks, the routers, the instances, the ports, the security groups, every part of the infrastructure for a single tenant. So we had that one template file that was for a single tenant. We parameterized it, so we could specify a particular version of an image that we'd spin up for a tenant. In cases of upgrade, you could specify a newer version. And most of our configuration was shifted off out of the OpenStack itself. So that allowed us to really adopt a sort of cattle mentality where we could trash all the VMs and have them all recreated and rebuilt within a few-minute period. This centralized configuration also aided us when it comes to upgrades. So we could spin up a second, newer version of whatever VM we had, have it configured all in the background, and then flip over a floating IP when we needed to. So yeah, here's just a very basic heat template. In reality, the ones that we had for our product were several hundred lines long. But the basic idea here is you've got a parameter that is the network, and you've got one resource, which is just the server, and that's connected to the parameter the network parameter that you've specified. These templates were checked into source control, so we had that level of control over what was being deployed. And finally, multi-tenancy. So multi-tenancy within OpenStack is achieved for us through creating a Keystone project for every tenant that we had. And then within that project, we'd spin up the set of resources through heat. So the Neutron overlay-underlay networking allowed us to define a tenant network, which was the same for every tenant, and then spin up VMs with the same IP addresses for every tenant. That allowed us to have the one solution no matter who the tenant was. You could easily just jump into, you'd know exactly what the environment was regardless of who the tenant was. So in this particular case, we've got a diagram of compute nodes. On one individual compute node, you'd have something along the lines of this. So you'd have a network namespace that contains all the VMs for the one tenant, and that namespace would propagate out through the Neutron node via GRE tunnel and keep that traffic isolated within the OpenStack layer. Right.
Cool. So once we'd decided that OpenStack was the right technology to use, we had to build some tooling to interact with the OpenStack APIs. This gave rise to Optic, our OpenStack project template instance controller, which is actually a backronym. We knew we were going to call it Optic before we'd worked out what that meant, if you couldn't tell. So it's essentially a Java library that acts as the glue between our cloud product and the OpenStack itself. So Optic was built to allow creating, updating, and deleting a tenant, but in doing that, it also deals with all the back-end OpenStack API calls that configure the instance itself. This all of a sudden meant that we could spin up an entire tenant environment in less than 10 minutes and have it completely configured, ready to go. The tenant environments weren't necessarily just single, simple VMs either. They were most commonly multiple VMs in a cluster, and each of the individual VMs had a very different purpose, from API servers to databases. We could even set them up in high availability configurations, and this was all ready to be used 10 minutes after the click of a button. So what does this actually mean for you? Imagine you had a request come in to spin up a new environment for a customer, and it's your job to create that tenant's environment for them. If you had something like Optic, you could go back to the requester 10 minutes later with all the information they need to start using their brand spanking new environment. Or even better, you can automate the entire process so they don't even have to speak to anyone. They could just fill in a form and then 10 minutes later start using your product, regardless of how complicated it normally would be to set up. So after our fellow IBMers saw how easy it was for us to do this for a customer, they wanted a piece of the action too. So we basically modified a few of the internals and then whacked a pretty basic UI on top of it, which made it accessible for the developers and the testers and the support people on our team. This immediately started saving us hours in testing time. If the end-to-end automation meant that any build could be spun up and have changes made to it or verified on it without requiring someone to sit there installing the builds and then configuring it, which is something that actually took us hours in the past. We hope to soon start even saving more time by using OpenStack and Optic and Ironic to perform builds on different hardware and hardware platforms, which will mean we're not just limited to testing feature changes, but we can test hardware-specific functionality and make sure our product's working on every platform that we're supporting. So for internal use, a real advantage of this tool came from the fact that installing the build was a one-time cost. So the install will take a while to complete the first time, as any install does, but after this point, the image is snapshotted. And then when a build is requested, that same build is requested in the future, the snapshot is used instead, which means that the time required to get the box up to the user is essentially the time taken to take that snapshot onto the relevant compute node, and then just boot time. And if you're really clever about it, there's also caching you can do to reduce that transfer time. And this advantage lends itself to being really useful for things like having the latest nightly build installed and ready for you and every single member on your team, ready to be used the next morning when you get in. So at this point, it's worth mentioning that this whole strategy doesn't just have to be for cloud deliverables either. This works for any sort of product that can be encapsulated in a set of VMs. And we personally have even thought about using it to test cross-product integrations for products that aren't even typically delivered on the cloud. So I guess we want to give you a bit of context for how we've used OpenStack. So we're going to talk a little bit about what we actually work on. So we both work on a product called Curator, which is what we're using Optic for, the internal testing and development of Curator. But Optic was actually built for a completely different product originally. But because of the power of it and OpenStack, we brought it to Curator with us. And we were able to do this with very few changes to Optic itself, which I think is pretty phenomenal given that these are two completely different products that we've been able to use this for. And it gives us kind of confidence in coming to you today to say that it's worth implementing regardless of what your product's application is, because you can take it elsewhere. So Curator is an IBM security intelligence product, a SIM. And for those of you who haven't heard the acronym before, it stands for Security Information and Event Management. But essentially what this means is we take, our product's purchased by companies, and then we can detect attacks on their network. We can help the customer respond to these attacks faster, and we're just making the job of security analyst easier. We use things like data correlation to reduce a lot of network events and flows into a single incident for the security analyst to look at. And then we use feedback from the user and from our other IBM security products to reduce noise and false positives. So the Curator SIM is most commonly deployed on-premise. We sell hardware and licenses which are spec'd to different customers' network loads. And then this is kind of usually achieved through a combination of, or 5 different combinations of components, which is what I've got on the screen. But there are many other ways of doing it. These are just the ones that we've been playing with the most.
Well, our development team does, yeah.
Yeah. So on the far left, we have a SIM console, which is a standalone appliance. The next 3 configurations are the SIM console with an additional component which provides some level of extended functionality. And then on the far right, we've got another standalone appliance, which is the Curator Incident Forensics box. So I'm just going to go through one of the ones that Dale and I personally use the most often, one configuration, but as I said, there's lots of different configurations. So here we have a flow collector, which takes all the flows from a customer's network and does some initial processing and aggregation of the data, and then it sends it on to the SIM console. So the SIM console is a completely different VM, and it has a number of components within it. And it does everything from deduplication to custom rule processing and licensing. But it then goes on to do the rest of the processing, the storage, and the display of the data. So as you can imagine, because the flow collector and the console are 2 very different boxes, they have very different setup and configuration requirements. So because of this, we needed different OpenStack templates to help us set up and configure each of the different types of boxes, and that's what we've created. They're pretty much the same, but they usually differ in network configuration, but we now have a set of 5 templates that we can choose from to spin up at any point. And these templates are reused every single time we want to bring up a new build. So it was kind of just a one-time time investment, I suppose, to create them. So all that we have to do for ongoing maintenance is to keep a track of which build version maps to which VM configuration, and thereby what template we need to use.
All right, so now what we're going to try and do is a quick demo of what we've built. We were going to try and do a live demo, but unfortunately, VPN connections are not playing nice today. So we luckily have this pre-recorded version. So this is the Optic UI that we've got. It isn't very fancy, but basically you have a list of projects that people on the development or testing team have spun up. And we can go in and create a project. Basic details, email address, and a name for the project. Fill those in. And then pick a template. So they were the templates that Holly was talking about before. And then for each VM that we have a version selector for, you'll pick out a list of available image versions. So in this case, we picked 2 builds with our product version, date stamp of the build, and a branch name. Git. All right, so we'll click create on that. The request has been accepted. So if you note the time here in the corner, it's a little bit blurry, but 10:07, yep. So we do a slight time jump, but it's 10:07 at the moment. So this is the full list of all the images that we could have chosen to spin up. You'll see the different types of images along the left there, flow collectors, forensics, SIEMs. So coming back to the project list and picking the project that we created just now, you can see the state has already gone to running. So previously we had a state of creating. So the state of running means that as far as OpenStack is concerned, its job is done, and we're just waiting for the product to boot now. So other details you can see on the screen are the VM versions that we spun up, as well as the IP addresses of the VMs that were created. So they were output from the heat template as outputs. And there's also a link to the console down there, hyperlink. So I think we're going to do the time jump. Yep, the time jump. So it's now 10:11, is it?
Yes, 10:11.
So 4 minutes and the product is booted and it's ready to go. So we're just going to hit the dashboard here. We use self-signed certificates for internal builds. And here we go. So within probably 5 minutes, we've gone from nothing to having a fully operational version of our product. Yeah, that's basically the summary of it all. All right.
So for Dale and I as developers, one of the most beneficial aspects of Optic, aside from the time-saving point of view, has been the confidence it's given us in our product. So we've been able to incorporate it into our automated testing infrastructure so that the usual process of testing any change that we make, it'll tell us pretty quickly that if we've accidentally broken something. So our current workflow looks a little something like this. The first thing that happens is we kick off a Jenkins build, which will also run unit tests and component level tests of the product, and then it'll let us know if anything's gone wrong at this point in time. Then once that's complete, the second half of the pipeline begins. There are kind of two things happening in parallel here. The first is that the ISO is generated, it's downloaded, it's installed and spun up in a project, an Optic project, ready for us to start using. And then while that's happening, the regression test suite that our QA team member QA team, I guess, has put together is run. And then if either of these come back with issues, we kind of have two options. If the fix is minor, we can fix it on the running VM that's ready for us that's still sitting there waiting for us to use it or delete it or whatever we want to do. So we could make the minor fix on there, check that it's worked, and then go away and make it permanent. Or if that's not possible, we go into code, we make the change, and we kick off the automated process again.
So aside from that, also we could, because our build environment is within a Docker container, we can spin up the Docker container on our Mac, we can run the binary that we build on our laptop, plumb it to the rest of the VM that's running, so we've got the rest of the system running remotely, and have our local process on our laptop. That's another quick way that we can do minor changes and have the rest of the system all still there.
Yep. And I guess having that and the rest of the pipeline has kind of given us the confidence that any change we make, we'll be able to detect if something hasn't worked quite right. And it's done things like it's even helped us notice issues that nobody's ever seen before. And it's not even something developers have to remember to do. It just is kicked off automatically every single time a new build is run.
Yep, so a quick little bit on our future hopes and dreams for this solution that we've built. One thing I'm hoping to learn personally this week is a lot more about Ironic. So our product, or our piece of the Curator product, is a network traffic device. So we'll sit on a network and we have requirements for certain hardware, certain network interface cards. So one of the things I'd like to expand to is to be able to install our images direct onto the hardware, because at the moment that is still a manual process. So by having this one solution and using OpenStack under the covers, hopefully there shouldn't be too much to change, if anything at all. The other thing we'd like to do is more cross-product integrations. So because we're quite flexible, we can change the template. It's very easy for us to add in another IBM product or even a partner product and spin up a new environment based on that. And it's very low on the priority list, but a fancier UI. The UI has been described as our ugly child, but we hope to fix that at some point in time.
It's all right, it's functional.
It's functional, that's the main thing. We're developers.
So with any good presentation about our story, we wanted to share a few of the key learnings that we had from this whole process, which has been quite a long process. It started 2.5 years ago, so we've just stuck with 3. The first thing is, with any good project, the beginning of any good project, you have to set your requirements early. So for us, that meant multi-tenancy, scalability, and flexible architecture. And because we had those requirements clearly defined from the beginning, we knew that OpenStack was going to be the right technology to go ahead with. The second thing is something that I personally learned from. So as I mentioned earlier, Optic was not originally built to SaaSify Curator. It was built for a completely different product, and that product required a lot more component-specific configuration. So when I was originally building this, there was a lot of the product tied into the tool. And then when we moved over to Curator, I had to strip out a lot of that components, product-specific configuration, which takes time. And if you design from the very beginning to make everything as generalized as possible, you can kind of save that and also hand it off to other products in your organization or other teams for them to just start using. And then the final piece of advice is related more specifically to OpenStack. So before going the whole 9 yards, there's a lot of things to learn, but Dale's thought was make sure you play with the technology manually before you go and try to automate everything and tie it all together. Heat templates in particular are really powerful, and having a good understanding of what you can actually do with them will end up making it a lot easier for you to create a really good tool or product in the future. So just a quick summary, within the space of a year, we've been able to adapt our infrastructure for 2 completely different IBM security products, and we've had to make very little changes to Optic and the surrounding infrastructure. Not only this, we can see how we can incorporate more other IBM security products into our tool, and there are actually other teams in our office looking to adopt the solution. Even outside of having the capability to support entire products, we have templates ready to go to spin up databases and API services and other just common shared infrastructure, which can be used by any team whenever they like. The flexible nature of the infrastructure has meant that we can create virtual machine environments that are suitable for any team member. We can spin up a single VM, we can spin up multi-VM high availability environments, we can do scenario-based demos, or we can implement cross-product integrations, all with very minimal effort. This has all been possible by creating one generalized tool to interact with OpenStack in a quick and reliable way. Optic was something I was able to create as an intern, working just 1 day a week, and it has gone on to save developers and testers and support hours and hours and time. We think that it was a great investment of our time, and we hope that through this you've been able to see how you might be able to use it to help you too. Cool. Any questions?
It's got to be something. Yep.
So say you want to support a new technology or a new team, new product that I'm working on, say object storage. Do we need to reach out to you so we can give you the requirements that we need so you can modify your Optic app, or it's already set to go?
So the question was, if we had another product come along, what's the process to get that integrated with what we've got? Is that correct? Yep. So basically, as long as it can be whatever it is, as long as it can be contained within a VM, and you know what network infrastructure is required to communicate with that new VM, and how it interacts from a networking perspective to the other VMs, then there's not much to do really. The heat template would be addition of a new server entry and connections to whatever security firewall rules that you need. But beyond that, it could come down to something like a dozen lines of code.
Just
Yeah.
as an extension to that, so just to make it clear, Optic isn't, we're using it for internal purposes at the moment. It's not something that we're using with the public. But I mean, if you wanted to implement something similar to that for your own purposes, come and have a chat to us and we'll talk about kind of in a bit more detail exactly what that would involve.
Yeah, ultimately we call out to the Keystone and the Heat APIs of OpenStack. They're all well documented on the web, and we've just put a layer above it that orchestrates those 2 services together. Yep, thank you. Any other questions from anyone else?
Cool.
All right.
Thank you, everyone.
Thanks for coming.